Welcome to lecture everyone. In this lecture, I'm going to discuss about a recursive function. Again, a very important topic, a very important concept for all of us to understand. Now, function inside a function is something that we are able to understand. Now, if you're going to call this recursive function, so again, this is a subset of a function inside a function. Let's try to understand that what is the meaning of this recursive call and how we can try to do a real-time implementation. So see guys, a recursive call is nothing but calling a same function inside the same function. That is something called as a recursive call, right? So function inside function means I'm calling maybe a separate function inside one of the function. That may be a case of a function inside a functions, maybe a separate case of function inside a function. But in case of a recursive call, what happens is that I'm calling a exact same function inside the same function. Let's try to understand with the help of couple of examples so that your thought process will be pretty much clear. So if I have to find out a factorial of a number, now what I do in general, so if I have to factorial of maybe 5, so what is a 5 factorial? It's nothing but 5 into 4 into 3 into 2 into 1. This is what, and this is how I will be able to find out the factorial, right guys, everyone? Okay. And this is going to give you 5 into 4. So 5 into 4 is equals to 20. 20 into 3 is equal to 60. 60 into 2 is equals to 120. 120 into 1 is equals to 120. Okay. So 5 factorial is going to be 120. Now how I will be able to produce a code for this one? So maybe I can produce a code not just in one way, maybe into a multiple way without even using a factorial. But here I'm going to use a factorial approach where I'm going to call the same function inside the same function, and I'm going to solve this particular problem. Let's see how. So here, so def factorial factorial is a function which I'm going to write. So where I'm going to try to mention n. N means n can be any number. So for which I'm looking for a factorial. Okay. Now, so whenever I'm supposed to write a recursive call, so I'm supposed to find out a base cases. What is the meaning of base case? A base case means for the smallest part, right? For the smallest part, what could be the final outcome? Means when I will keep on breaking down these things, 5 then 4 then 3 then 2, which simply means that 5 then 5 minus 1 then 5 minus 2 then 5 minus 3 then 5 minus 4 so on, right? So what will be the smallest part, so where I will be able to, like, I won't be able to further break it down. So obviously smallest part is going to be 0. So 0 factorial is going to be 1, right? 0 factorial is going to be 1. So after this, what will be the number? Number is going to be 0. So here, what I can do is I can write a condition. I can write a smallest case. I can write a base condition for this one. So I can write maybe over here that if n is equals to, right? If the number that someone is going to pass is equal to 0, is equal to 0, in that case, what we should do? So maybe we should return what? We should return 1. Means when someone is going to pass 0, the smallest possible number for which someone will look for the factorial. So if someone is going to pass 0, so return is equals to 1. Obviously, factorial of 0 is equals to 1, right? Else what someone is supposed to return? So else someone is supposed to return n into, so someone is supposed to return basically n into same factorial of what? Factorial of n minus 1. This is something, and this is how I will be able to write the function. Now what is the meaning of it? Let me explain you in a detailed way by taking a manual example. So here I'm going to pass 5. I will be able to get 120. Now how I'm able to get 120? Let me explain you manually. So see guys, what will happen in case of this approach? I'm just trying to call the same function factorial inside this particular function, right? So simply means that yes, I'm able to do this recursive call. This is something called as a recursive call. Recursive call means I'm calling a same function inside the same function. Simple. Okay, fine. So I'm just trying to do a recursive call over here. Now, so whenever I have to do a recursive call, obviously I have to end this recursion somewhere. Otherwise, it will go in a infinite loop. So keeping that in mind, so we always try to form what? We always try to form the base condition. Now, what is the base condition? So see, if someone has to find out the factorial of n, which is 5, right? For in my cases, which is 5. So obviously, I have to do what? So 5 into factorial of what? 4. Technically, it's a 5 minus 1. This is what I am supposed to write. Yes, this is this is how I am supposed to write. Then 5 into factorial of 4. Again, I have to break it down. So what will be there? So 4 into factorial of 4 minus 1, which is 3. Then again, if I have to break it down, so 5 into 4 into 3 into, right? 3 into factorial of 2, 3 minus 1. Then again 5 into 4 into 3 into 2 into factorial of what I have to write? So 2 into factorial of 1. Factorial of 1 I have to write. Then 5 into 4 into 3 into 2 into 1 into 1 minus 1, 0. So factorial of 0 I'm supposed to find out. Okay. Now further, I will not be able to break it down. For negative number, I won't be able to find out the factorial. So here, this is my base condition, right? This is my base condition. Factorial of 0 is my base condition. We all know that for factorial of 0, what is the value? Value is going to be 1. So keeping that in a mind, we have written over here that if n is equals to 0, if factorial of 0, so if n is equal to 0, simply return 1. Simply return 1. Now, if someone is going to return 1, now you will be able to do a rest of the calculation in the easiest possible way, right? You will be able to do a rest of the calculation. This is what we have written over here, that keep on breaking it down, keep on breaking it down. Now here, so whenever you are going to call this function, right? Whenever you are going to call this factorial of 5, internally, what will happen is, so internally, if you are going to enter 5, so n is equals to 5, it will not be able to go over here. So it will go over here, return what? Return 5 into factorial of 5 minus 1, which is basically factorial of 4, which I have written before, right? Then again factorial of 4. So it will try to call again what? Again it will try to call this one. Same function it will try to call. So 5 into, so n is equal to 4. This time n is equals to 4. It will again come over here. Then it will try to break it down this part into 4 into factorial of 4 minus 1, which is going to be 3. Then again it will try to, this function it will try to execute. So it will keep on executing it, keep on breaking it down unless and until you are not going to decompose it into this particular part. Once it will be decomposed to this particular point, what will happen? Simply give the outcome by doing a manual calculation. So in case of factorial, we always try to find out a base condition, so where things are going to stop itself, and then just call a function inside the function. Now let me explain you the same thing with the help of some more example. So I think we all are aware about the Fibonacci series, right? So in the Fibonacci series, the next number is going to be the summation of the previous two numbers. This is what happens, right? Next number is going to be the summation of the previous two numbers. This is how I will be able to write down the Fibonacci series. Okay, and again, we have already written a Fibonacci series kind of a program in our past. So this is nothing new. But here, so by using a recursion, I'll try to write it. Fibonacci series underscore series. Fine. So let's suppose someone is looking for a Fibonacci. So till nth number. So here, what I can do is, so in case of Fibonacci series, what happens? Let's try to consider that first. So there will be 0, there will be 1, there will be 1, right? There will be 1. And then 1 plus 1, 2, 2 plus 1, 3, and so on. This is how things are going to start. Now, if someone is going to say that I'm looking for just a Fibonacci series, right? Fibonacci series maybe for a minus of 1. It is going to be what? It is going to be that number itself I'm going to return. Let's suppose if someone is going to say that I'm looking for a Fibonacci series just for 0. Means 0th Fibonacci series I'm going to generate. What I will do is I'll just try to print this one. That's it, and nothing else I'm supposed to do. So that may be a base condition for me. So here, as a base condition wise, I can try to write it down that if n is lesser than or equal to 1. So if someone is going to enter that, okay, fine, so I'm just looking for one Fibonacci series, in that case, do what? Return simply that particular number. Else try to do what? So else try to return RETURN, return. So Fibonacci series of what? Fibonacci series of n minus 1 plus Fibonacci series of basically n minus 2. Execute. Now if I'm going to call this Fibonacci series, And let's suppose if I'm going to pass 5 over here, okay, so 5 over here, maybe I can try to pass maybe 8 over here. I'm able to get the 21, means eighth Fibonacci series number. If I'm looking for maybe a 0th Fibonacci number, 0. If I'm looking for minus 1th Fibonacci number, minus 1. If I'm looking for 1th Fibonacci number, 1. If I'm looking for maybe a 2th Fibonacci number, it's a 1. If I'm looking for 3rd Fibonacci number, it's going to be 2. Now, how it is able to do a calculation? Let's try to understand by taking one example. So let's suppose if I'm going to give 6 over here. So 6th Fibonacci number is basically 8th. How it will be able to find out? So see guys, it always starts from what? 0, then 1, then 1, then 1 plus 1, 2, 2 plus 1, 3, 3 plus 2 is equals to 5, 5 plus 3 is equals to 8. So 1, 2, 3, 4, 5, 6, 7. I'm looking for what? 6th Fibonacci series. It will start from 0, then 1, index is equal to 0, 1, 2, 3, 4, 5 and 6. So 6th Fibonacci series, it is able to give it to me, as you can see, right? 6th Fibonacci series number, it is able to give it to me. How it is able to give me this 6th Fibonacci series? So I have entered 6 over here, right? I have entered 6 over here. So this will call this function n is equals to 6. Now if n is equals to 6, it will come where? It will come over here, right? It will come over here. It will not go over there. N is not lesser than equal to 1. It will not go over there. It will come over here. Now Fibonacci, I'm going to write Fs, right? So let me write down Fs. So Fibonacci series n minus 1 means 6 minus 1. 6 minus 1 is what? 5 plus Fibonacci series 6 minus 2. Fibonacci series 6 minus 2, which is going to be 4. So I have to find out Fibonacci of this plus Fibonacci of this. Okay, fine, not an issue. Let's break it down. So Fibonacci of 5. So Fibonacci of 5 is nothing but Fibonacci series of basically 5 minus 1, 4 plus 5 minus 2. So 5 minus 2, Fibonacci series of 3 you will have to find out. Then again Fibonacci series of 4, this will become 4. So here Fibonacci series of 4 minus 1, 3. Fibonacci series of 4 minus 2. So Fibonacci series 2 you have to find out. Then again you have to break it down. So Fibonacci series of 4. So Fibonacci series of 4 is nothing but Fibonacci series of 3 plus Fibonacci series of 2. Fibonacci series of 3 is nothing but Fibonacci series of 2, Fibonacci series of 1. Fibonacci series of 3 is nothing but Fibonacci series of 2 and Fibonacci series of 1. You have to find out. Then Fibonacci of 2 is nothing but Fibonacci series of 1 and Fibonacci series of 0 you have to find out. Fine. So this is the numbers that you have to find out. So Fibonacci of 3 is nothing but what? So Fibonacci of 3 is nothing but Fibonacci series of maybe. Okay, so let me do one thing guys. Let me write it down once again, the entire set in a little bit cleaner way. Okay. So Fibonacci series for 6, I'll try to find out. For the same number, I'll try to find out. So here I can try to write, I can start from here itself. So Fibonacci of 6, f is a notation for the function I'm going to consider. So Fibonacci of 6, if I have to find out. So I have to decompose it in this way, this two way, right? I have to decompose it into these two ways. So Fibonacci of n minus 1 and then Fibonacci of n minus 2. So it's going to be Fibonacci of n minus 1, so which is going to be 5, and Fibonacci of 4. Okay. Then again 5 I have to decompose. So Fibonacci of 4 and Fibonacci of 3. Here Fibonacci of 3 and Fibonacci of 2, in which I will be able to decompose. Now Fibonacci of 3, Fibonacci of 2, Fibonacci of 2, Fibonacci of 1, Fibonacci of 2, Fibonacci of 1, Fibonacci of 1, Fibonacci of 0. Now Fibonacci of basically 2, Fibonacci of 1, Fibonacci of 1, Fibonacci of 0, Fibonacci of 1, Fibonacci of 0, Fibonacci of basically 0, and then minus 1 means minus 1 itself you will be able to get. There is no meaning of it. So again Fibonacci of 1 and then Fibonacci of 0, Fibonacci of 1, Fibonacci of 0, Fibonacci of 1, Fibonacci of 0. So everything, Fibonacci of 2. So Fibonacci of 2 is nothing but Fibonacci of 1 and Fibonacci of 0. So you will be able to find out that I am able to decompose everything into its lower label, right? I'm able to decompose everything into its lower label. Now, just try to do the computation. Fibonacci of 1 and Fibonacci of 0, right? Fibonacci of 1 plus Fibonacci of 2 is going to be what? Fibonacci of 2 is going to be this plus this one, right? So 1 plus 0. So here, what is the like value of Fibonacci of 1? So Fibonacci of 1 is equals to 1 or lesser than equal to 1 is equals to same number. So Fibonacci of 1 is basically going to be 1. Fibonacci of 0 is going to be 0. So here Fibonacci of 2. Fibonacci of 2 is going to be what? 1 plus 0 is equals to 1. Fibonacci of 2 is going to be this one. Now Fibonacci of 1. So Fibonacci of 1 is going to be what? It is going to be 1. Fibonacci of 1 is going to be what? 1 and then 0, then 1 and then 0. Fibonacci of 1 is going to be 1. Fibonacci of 2 is going to be what? 1. Fibonacci of 1 is going to be 1. Fibonacci of 1 is going to be 1. Okay, fine. So if you will try to do carry forward it, so here Fibonacci of 3 is going to be what? 2. Okay. Fibonacci of 2 is going to be what? 2 is going to be 1. Fibonacci of 2 and then 1, so 1 plus 1. So Fibonacci of 3 is equals to 2. Fibonacci of 4 is equals to basically 3, right? So Fibonacci of 3 is basically 2. Fibonacci of 2 is basically 1. So Fibonacci of 4 is basically 3. So 3 to 5. So here Fibonacci of 5 is equals to 5. Fibonacci of 4 is 3. Now what is the Fibonacci of 6? 5 plus 3 is equals to 8. This is the answer that you will be able to get. So I'm just trying to decompose it. I'll keep on decomposing it till its lower label and then finally I will be able to find out the answer. So this is how this Fibonacci series is going to return the values, guys. Hope all of you are able to understand. So simple, keep on breaking it down unless and until I'm not able to reach out to my base condition. So once I will be able to reach out to my base condition, simple, drop it and then your work will be done. Okay, so this is one of the example, guys. Now let's try to understand the another example, summation of the list. So let's suppose I have a list over here and maybe if I have to do a summation of the list element, there are elements over here. I can simply call some function. I can even call a for loop and even I can try to use some other methods to find out a lambda function I can try to write and I will be able to find out the summation of the list. But let's suppose I have to solve this problem with the help of a recursion. Recursion means calling a function inside the function. Okay, so how I will be able to do it? Let's try to understand. Now, so here def sum underscore list. This is a function which I'm trying to create where I'm going to pass a list. Let's suppose L I'm going to pass. Okay. Now, what is a base condition, right? What is the base condition for this particular list? So if there is no list, right? What is the base condition? So if there is an empty list, if there is a no list, so in that case, what will be the summation? Summation is going to be 0. That is the base condition. That is the minimum condition which is possible. So I can write if not list, if not list, so sorry, if not L, so means if this doesn't even exist, return what? Means return is equals to 0. This is the base condition. Else do what? So else you have to find out or you have to return what? So return L of 0 plus you have to return what? So you have to return summation of a list, means same function I'm trying to call, which is going to start from 1 till infinite. Infinite means till the time we have a data inside the list. Now, how this function is going to work, let me explain you that part. Let me show you some of the result over here, guys. So here, sum of the list, I'm trying to pass L list that I have and it is giving me 18. So yes, 3 plus 4 plus 5 plus 6 is equals to 18. This is something which I am able to find out. Now, let's try to understand with the help of these problem statements. So see, guys, if not in list, if means there is no element in the list, return 0. Very simple. Else return this one. So here I'm going to pass a list. This is the data of the list which I'm going to pass. So it will return what? It will return what? L of 0. So my L is having 3, 4, 5 and 6. Okay, so return what? Return L of 0. What is L of 0? So L of 0 is basically 3. It is going to return plus plus plus. It is going to return sum of the list. So same function, sum of the list function for what? List starting from 1 till, means till 0 I am able to extract it. So starting from 1 till last. So 4, 5, 6 means do the same thing for this particular list. Let me write it down in a beautiful way. Okay, so here I have a list 3, 4, 5, 6. This is the data which is available inside the list. Okay, this is the data which is available inside the list. Now I'm going to pass this inside this particular function. Return what? Return list of 0. So list of 0 is what? 3. It is going to return plus. So plus sum of the list, let's suppose, and list starting from 1 till last. It is going to return. So it is going to return 4, 5, 6. Okay. Now this is again summation of the list I have to perform. So this time what I will do? 3 plus. Again same thing. So this will call over here. This will be called over here. So it will perform the same thing, list of 0. So 4 plus summation of list this time, and list contain 5 and 6. Okay, fine. Now same thing will be called. So 3 plus 4 plus 5 and then summation of list of 6 element. Okay, fine. Now 3 plus 4 plus 5 plus 6 will be called, and summation of list with what? With the empty element. There is no element because I am able to extract each and everything, right? Now there is no element at all. There is no element at all. So it will return what? It will return 0. So 3 plus 4 plus 5 plus 6 plus 0 is equals to 18. This is how this function is working, and this is how you all are able to get the result. So again, this is another example of a recursion. So with the help of function inside the same function, I am able to solve some of the examples, some of the operations over here. Okay, so this is like one of the again simplest example, guys, that you all will be able to find out. So likewise, there are so many different recursion example you all will be able to find out, and there are very interesting problem you all can find out even in case of a data structure and algorithm, which I'm going to teach you in a future. As of now, I'm just giving you a simple and basic example so that you all will be able to understand the basic meaning of a recursion, so that going forward we will be able to solve not just a simple problem but a very complex problems as well. With that, thank you so much everyone. Try to practice couple of problem by yourself based on the recursion, and then let me know if you're facing any kind of a issue. I'll be happy to explain you with many different kind of a example. With that, thank you so much everyone.